So I'm going to do this, evaluate this improper integral here. And an improper integral is an integral that goes to infinity or starts at negative infinity, or, you know, it's improper, it's just weird. But this is how I like to solve it. So we can never really get to infinity. You'd have to, it's an uncountable number. It's not a number. You can never really get there. So what I have to do is rewrite it like this. The limit as b approaches infinity of the integral integral of 1 over x, this is annoying, but the integral of 1 over x evaluated from 1 to b. So now you're evaluating at this number b, which isn't infinity because you can never get there, but it's really, really close. You know, the limit's approaching infinity, but it never gets to infinity. So we'll integrate this, and we know that this is the natural log of x. That's the integral of this. So we'll evaluate this from 1 to b. So when you do that, you'll get the natural log of b minus the natural log of 1. And this is all as the limit of b approaches infinity. You got to keep that idea in mind. So the natural log of the natural log of 1 we know is 0. And this, as well as the limit is, b approaches infinity, it's the natural log of infinity. Well, you can't really take the natural log of infinity, that just equals infinity. And then infinity minus 0 equals, obviously, well, infinity minus or plus anything is just going to equal infinity. So the answer to this is infinity. This doesn't exist, and this diverges because the improper integral is infinity, and that just means this integral doesn't really have an area under it, just keeps going up and up and up and up. So that's the solution to this improper integral. So here's another improper integral. We want to integrate from 1 to infinity of 1 over x squared. Now, I think it's easier to rewrite this like this. The integral from 1 to infinity of x to the negative 2 with respect to, and then we're integrating with respect to x. Now, same idea that you can't really integrate to infinity, but we could go close. We'll say the limit as b approaches infinity, and we'll integrate from 1 to b of this right here. And let me clear this up real quick so we have some more room to show all our work. So here we have it rewritten. The limit as b approaches infinity of x to the negative second power, and we're integrating from 1 to b. So let's integrate this, and we'll get x to the negative first divided by negative 1. So this is the same thing as negative x to the negative 1, which can also be rewritten as 1 over negative x, or negative 1 over x, doesn't really matter. So now we have this integrated, we could check, what the area under the curve is. We'll evaluate this from b to 1. Now the thing is, it's the limit as b approaches infinity. So this is pretty much 1 over infinity minus negative 1 over 1. Am I right? So this goes to 0. And then when you evaluate this is the same. Negative minus a negative is a positive. So this is just 1. And that's your answer. The area under this curve, 1 over x squared, from 1 to infinity is 1. So that's how you solve for that improper integral.